Given f of x equals negative x to the third plus 6x squared minus 9x, where is the function concave up and concave down? Well, my function is going to be concave up when the second derivative is greater than 0. It's going to be concave down when the second derivative is less than 0. So what I need to do in order to find the second derivative is I need to find the first derivative first. So f prime of x is going to equal power rule. Negative x cubed becomes negative 3x squared. Positive 6x squared is going to become plus 12x. Minus 9x is minus 9. Now my second derivative is going to be power rule again. So f double prime of x is going to be negative 6x plus 12 plus nothing. Okay, so what I have to do is I have to find my inflection points. My inflection points exist when f double prime of x is equal to 0. Okay, and I'm going to have one inflection point, negative 6x plus 12. I'm going to have one inflection point, and that's going to happen at, well, let's see, minus 12, negative 12 equals negative 6x, divide by negative 6, divide by negative 6, x equals 2. So what I can do is I can make myself a sign chart for f double prime. 2 is my magic number. What I need to do is I need to find out where my second derivative is positive and where my second derivative is negative. I know it's 0 at 2. So if I were to take, like, I don't know, 0 and plug it in, or if I were to take 10 and plug it in, that'll help me figure out if this is positive or negative here, or if this is positive or negative here. So f double prime of 0 is going to involve me taking this guy right here and substituting in 0. Negative 6 times 0 plus 12 equals positive 12, which means you are positive right here. F double prime of 10 is going to be negative 6 times 10 plus 12 is negative 60 plus 12, which is like negative 48, so definitely negative. So if your second derivative is positive, that means you are concave up. If your second derivative is negative, that means you're concave down. So we could say that we are concave up on the interval negative infinity to 2, and we can say that we're concave down on the interval 2 to infinity. And this makes sense. This is a cubic. Cubic looks like this. So at some point here, and that point is going to be 2, we go from concave up to concave down. And I know this cubic looks like that because of the negative in front of x cubed. So it all checks out. It all checks out, baby.